Thanks very much, Tom. Okay, so yes, as Tom said, I'm Russell Keith-Magee. For those who don't know me, I'm actually a Perth local, born and bred, and my day job is as the CTO and co-founder of TradesCloud. We're a software as a service for tradespeople, plumbers, electricians, that sort of thing. But that's just my day job. In my spare time, I've been a core developer on the Django project since January of 2006. I've been president of the Django Software Foundation since 2010. The DSF is the IP, legal and fundraising arm of the Django project. What's Django? I'm guessing many people in this room will know the answer, but for those who don't know, it's probably the most popular web framework using the Python programming language. There are lots of other high-profile, high-traffic sites using Django. Instagram is a Django site. Much of Mozilla's internal infrastructure, including the plugin repository, is a Django site. Discuss is a Django site. And there are a litany of others, ranging from everything from journalism to media and everything in between. What I want to talk about today are lessons learned building a large open source project like Django, and analysis of the sort of decisions that you might need to make along the way. This includes architectural decisions, architectural lessons, which is what sort of the title of the talk is really alluding to. But there's also some community management lessons, and somewhat surprisingly, a little bit of overlap between the two. And whilst I'm coming at this from the experience of developing and being involved in a large open source project, some of the decisions that I'm talking about here won't matter quite as much to smaller projects as they will to larger projects. There is still some applicability. Smaller projects will still face these decisions or variants of them in their own sort of development and planning processes. I'm coming at this from a very Python-heavy background. You know, Python is my weapon of choice for most things, but I have used lots of other languages and tools over my year of programming history. But the sort of decisions that I'm talking about here aren't just Python things. They're really about architecture, gross project architecture and engineering philosophy, much more than it is about the specifics or the quirks of a particular language. The only place that language-specific features really feature in this sort of discussion are where the language itself, or usually more specifically the features of the language environment, have an influence on your decision-making process and engineering priorities. I'll come to some examples of that later. It also isn't just about web frameworks. Now, I obviously am going to be talking about Django as an example of a project which we've had some success and I've got a lot of involvement with. And try to be sort of analyse why we've had that success. And to be clear, this is all post hoc analysis. Very, very little of this was actually planned. Django's success was as much a surprise to the people involved as it was actually, you know, a strategic plan. My comments here today are mostly the result of my and conversations I've had with other members of the core team and our analysis of trying to reverse engineer the success that we had, which we achieved mostly by accident. Now, for the sake of my arguments and for the sake of an audience that probably doesn't necessarily know or want to know the internal politics and internal structures of Python web frameworks, I'm going to simplify a whole bunch of stuff, not the least of which is that there are a lot more Python web frameworks that I'm likely to mention over the course of today. I'm also going to deliberately caricature a couple of web frameworks that, in order to illustrate a point about high-level project decisions. If you're trying to use this talk to decide which web framework you should learn or which web framework you should use, you're going to be disappointed, probably misled. Because I'm going to gloss over and simplify a whole lot of details for the sake of a larger argument. Now, if you want to learn about web frameworks, go seek out a web framework tutorial. There are plenty of them. This isn't the talk you're looking for. So when you're dealing with a large project like Django, one of the big questions, and obviously the title of this talk, is what sort of framework do you want to be? Do you want to be best of breed or do you want to be batteries included? If you're dealing with a small library or a small project, that sort of distinction doesn't necessarily exist. You know, if you're building a JSON parsing library, you need to parse JSON. You need to, once your library can handle inputs in some sort of textish-like format and provide outputs in some form of structured data format, the job's basically done. You know, you've got a very, very simple task that needs to be achieved. There aren't too many options involved. There might be some flags to determine how certain inputs are handled. You know, will recoverable syntax errors be silently fixed or strictly reported? But they're not like they're big sub-problems. It's very easy to keep architecturally pure. You're just kind of solving one problem. But when your problem space gets bigger, there are going to be lots of other little sub-problems that have distinct approaches. How do I make this request from a browser turn into a rendered web page? Is this sort of the high-level problem that is faced by any web framework. But in order to solve that problem for a modern website, you've kind of got a whole bunch of other little problems. You know, you need to say, how do I serve my page? How do I render the output? How do I query my data store to retrieve content? How do I accept and validate user input? At that point, you're faced with a choice. Is your project going to be best of breed, or is it going to be batteries included? Now, Those terms are very much weighted by the Python language community, and they aren't sort of software engineering constants. So I'll start by defining my terms. Django is what is referred to in the Python community as a batteries included framework. That is to say, the phrase comes from the idea that when you're down at the toy shop, all the really cool toys come with batteries included. So you can take them home, take them off the shelf, take them out of the box, and they just work. You have one big box, one big package that contains everything you need to get going. The internals can still be well designed, they're decoupled and all the rest of it, but from the end user's perspective, the person who actually has to use this thing at the end of the day, there's just one lump. The project as a whole has a single identity. For example, the documentation is a one-stop shop. You don't have to go and reference a whole bunch of external sources. You can just get going with what is in the box. When you download Django, you get a database layer. It's called the ORM, the Object Relational Manager, a template library, a forms library, all the pieces you need to build a fully functioning and reasonably featureful website. The documentation, in turn, talks about Django as a whole and as a cohesive system. The alternative approach is where you don't write new code. You use your project as essentially just a set of glue tying together existing projects that are being independently maintained. It isn't just about using libraries, though. By JSON parsing example from before, it could itself be leveraging other tools. It could be leveraging other utilities like GNU Bison or something like that, some sort of analog. My JSON parsing library is a layered extension of one or more other libraries trying to build forward. Django uses libraries as well. What I'm talking about here is about things at a framework level, where you're dealing with a larger architectural amalgam, where each part is equally important to the whole. Each part has its own documentation, its own tutorials, its own coding conventions, its own tests, its own management team. The framework, which is really trying to describe a solution to a bigger problem, is providing the glue to tie all the parts together. It's the situation where the umbrella project isn't adding a whole lot of code to the mix itself, but is primarily a description about how to use a bunch of parts to achieve a larger goal. As I said earlier, Django is currently the most popular Python web framework, but it isn't the only Python web framework by a long stretch. One of the bigger competitors, it's been around sort of similar timeframes depending upon how you could deconstruct the family tree, is a web framework called Pyramid. Pyramid is a good example of a best-of-breed framework. There isn't a whole lot that in itself would be called Pyramid code. There's a little bit of glue, and there's a whole lot of documentation about how to get all these bits to play together. How to use SQL Alchemy as a data store, how to use a particular forms library, how to use this particular routing library, and so on. This is sort of then leads to the arguments between Django camp, Pyramid camp, and so on, which essentially come down to Django being criticised, and this is historical and current criticism, as being a not invented here framework. NIH is a common counterpoint to the batteries included approach. Because in this case, the Django community hasn't leveraged tools provided by people who aren't in the Django team. Projects like Pyramid are presented as projects that do it right, because they use other libraries and they don't duplicate effort rather than building their own. The problem is that this analysis completely misses some of the fundamental points about the history, goals, and architecture of the two projects. Now, as an aside, I am a member of the Django Core team, so I've got a dog in this fight. I don't want this to devolve into a Django versus X talk. What I want to do is explore the reasons why this argument gets leveled, look at the differences between the two, and look at the benefits and costs of both. My aim here is to look in general at how projects are structured and maintained and look at the consequences of those decisions. And as I said before, I'm also massively simplifying here. The batteries included versus best of breed dichotomy is a massive oversimplification. Reality, as with all things, is much more nuanced. But it does serve as an example, and it's a real set of criticisms that do get levelled against Django regularly. I'm also taking things to extremes. There are some parts of Pyramid that are genuinely new code. Django does have some external dependencies, but the caricature suffices for the purposes of this discussion. It's also worth pointing out that these are two extremes. Hybrids are possible. It's not too hard to imagine a theoretical web framework that provided a routing library and a template library as built-ins, but used a third-party library to access the database, for example. Okay, so you've got your own project, your own thing you're working with. You're faced with these sorts of decisions. You can take the middle ground. Why would you pick one over the other? Well, sometimes, and this is an important one from the Django perspective, you don't pick an approach. The approach picks you. This is a family tree of popular Python web frameworks over the last 10 years. Django went public in 2005. It was in development as an in-house closed source project for close to 2.5 years prior to that. At the start of this talk, I said Django's main competitor is currently Pyramid, and that's a very carefully selected word because in 2005, the major competitor to Django in the Python space was a web framework called TurboGears, which is also was also a best of breed framework. Pyramid didn't actually exist in its current form until 2010. Pyramid comes from a long line of code that stretches all the way back to Zope in the mid-1990s, and the late 90s and early 2000s was essentially a process of refactoring and rebuilding and refactoring and rebuilding until we ended up with a thing called repos.bfg, which was really not much more than a URL dispatching tool, which then merged with Pyramid, which then merged with pylons, and essentially we ended up with another best-of-breed framework at the end of the day. Why does that history matter? Well, it's very hard to be best of breed when the breed doesn't exist yet. Django, as I said, was open sourced in 2005. As a project, it started in October 2003. And at that time, there really wasn't any such thing as an object relational mapper, what Rails people would think of as active record, which is the object representation of what you've got in your database. This was an emerging idea at the time. So Django built its own. Looking at the current state of affairs and saying Django should have used SQL Alchemy is a problem when SQL Alchemy didn't exist in the time frame we're talking about. And yet this is an argument that gets levelled at Django for not using SQL Alchemy. It's only possible to have a best of breed when the breed has actually had time to establish. SQL Alchemy was one of several database interface layers that have been developed over the last 9 years. It's now, after 9 years of development, that we can all, with hindsight and experience, look at SQL Alchemy and say, yeah, that's probably the one you should be using. That is the most mature and best one we've got. And that's, Pyramid has that option of using SQL Alchemy, although interestingly, that's not what Pyramid says you should do, but I'll come back to that point. If you're in a new problem space or you're representing a new approach to an existing problem space, sometimes you don't explicitly pick batteries included. It picks you because you're the one who has to supply the batteries because they don't exist yet. Picking best of breed early can also be detrimental. Let's go back and have a look at our family tree again. TurboGears 1 was originally released in 2005, pretty much about the same time as Django was open sourced. And it being a best of breed framework made a bunch of architectural decisions. It used SQL Object as a database layer, it used Kid as a templating engine, it used CherryPy as a routing engine. TurboGears 2, released in 2007, changed almost every single one of these components. It said you should use SQL Alchemy for the database, Genchi for the templating engine, and Pylons as the routing engine. As a result, for almost all intents and purposes, it was a completely different project. Migrating from TurboGears 1 to TurboGears 2 was a major problem. It really wasn't a version upgrade. It was rewrite your entire project with this new tool, which just happens to share a name as the old one. And as a result, TurboGears lost a lot of project momentum to the extent that it practically killed the project. So if you pick your best of breed combinations early, you run the risk of picking the wrong one, and then you have to deal with the aftermath. This then obviously raises another important point, the role that backwards compatibility plays in long-term project viability. TurboGears essentially had no backwards compatibility between two major releases that were just 2 years apart. On the other hand, Django has currently a backwards compatibility policy which guarantees that code written today will continue to run for quite some time in the future, and that any deprecations or changes will be phased in over a 2-release cycle, which means you're looking at an 18-month to 2-year chronologically. And there's also, on top of that, long-term support releases which guarantee support beyond that time. How much does that matter? Well, it depends. Time can be relative in this sort of thing. If you spend your life working on short-term contracts, delivering sites without a long-term maintenance overhead, say promotional websites for an event or sites supporting an advertising campaign that's only going to run for a couple of weeks, you don't have long-term problems. You can finish a job, you can move on to the next one. Every time you start again, you're free to try something new. You can experiment a little bit. You can replace something that didn't work well last time. You're looking at the world through glasses that think that 6 months is a long time. However, if you're engaged in a multi-year project, you really care about long-term maintainability. In a former life, I was involved with the Joint Strike Fighter program. It's the multi-billion-dollar project to develop a next-generation F-35 Lightning II fighter for Australian, US, UK, New Zealand, blah, 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 air forces. And at the point of conception of the project in 1990, they didn't anticipate delivering a working airframe for 20 years, and they're late. And before it became operational, the design plan, the implementation plan for this aircraft planned on doing 2 full rebuilds of the avionics subsystem. If you're in this space, you really care about long-term maintenance. You don't want the world shifting underneath your feet every 3 months. You can't use any project that doesn't have a 10-year support plan in place. 6 months is a rounding error in this work view. A good example of this in practice is a quote from Maciej Ceglarski, who's the owner, maintainer, CTO, whatever, of Pinboard. He says, "A rule of thumb that has worked for me is that if I'm excited to play around with something, it probably doesn't belong in production." And yeah, I agree with him. Excitement is not a property that I aspire to when I'm thinking about my production servers. Boring is a virtue in production. Boring is predictable. Boring won't wake you up at 3 a.m. having trashed half your data. Now, again, I'm not saying that one approach is right and one approach is wrong. Just that the properties that you value in projects will very much depend upon your perspective. Backwards compatibility does come at a price. It's a loss of flexibility. By not enforcing backwards compatibility between releases, TurboGears was in a position to explore new and possibly better options. On the other side, whenever Django wants to make a change, we need to actively consider the impact on existing users because we don't want to cause unnecessary headaches. This makes it a lot harder to introduce new features or to do big refactorings that we know really need to be done, because we can't just do it. We need to work out a phase-in strategy that doesn't impact existing users adversely. So is the price worth it? Well, in the case of TurboGears, they took a gamble, and in their case, it didn't pay off for TurboGears as a project. But the result was the emergence of Pylons and Pyramid, which utilised better options. So there's an argument to be made that the community as a whole really did benefit. However, one of the reasons Django is actually considered and is used by large organisations is because of the long history of stability. There's a lot of value in moving fast and breaking things. It allows you to try out new ideas, and this is great. But there's also a lot of value in being boring, stable, and predictable. You need to know your audience. And it's also worth pointing out that backwards incompatibility is an architectural decision all on its own. It isn't tied to the batteries included best-of-breed decision in itself. TurboGears could have maintained backwards compatibility by not changing all of its internals in one release, or at least providing a much softer migration path. TurboGears could have Django could have adopted a don't care policy for backwards compatibility and be just as incompatible between micro releases as TurboGears 1 to TurboGears 2 was. It isn't, sorry. Yes?
Sorry, I had a question. I wasn't telling you yet.
Oh, okay.
Lots of time. I was just wondering why you said it didn't pay off for TurboGears. Did their adoption drop off a lot?
They are, for all intents and purposes, a non-existent project now. They exist. They have a website. They, for like a year and a bit, didn't do any significant work on the framework as a whole. Interest died off, and it basically disappeared. Sorry. Question was why didn't that work out for TurboGears? So yeah, it isn't just as simple as batteries included, and therefore you get backwards compatibility for free. You do actually have to make a decision here. One of the reasons that best-of-breed frameworks give in their favour is that it allows you to pick and choose components. If you don't like one of the pieces, you can just change it out and pick the one that you do like. TurboGears, a good example of this. They started with a recommended set. They said these are the tools you should use. And they also really reinforced the idea as part of their documentation chain that if you didn't like Kid templates, you could use Mako, you could use Genshi, or you could use any of these other options. It was up to you to decide. Pyramid, alluding to a point I said earlier, Pyramid tackles this in a different way, essentially avoiding specifying anything altogether. If you visit the Pyramid tutorial page, they've got 2 tutorials and 4 example projects as sort of a getting started guide. Across those tutorials and examples, 6 of them in total, they use 3 different templating languages. There's 2 different data stores, 3 if you count SQLite native access. Pyramid has essentially avoided the TurboGears problem of specifying the wrong thing by punting on the problem and specifying nothing. Picking and choosing can be a virtue. It does encourage you to think about the specific problem that you've got, pick an appropriate solution to that problem. It's the best-of-breed approach at its best. But is the choice of batteries what you need or what you're trying to achieve at a framework level? Why is changing batteries a virtue in a framework, like in sort of the web space like Django? And to be clear here, I'm talking about frameworks. I'm not talking about in-house projects where you've made a decision to use a library and then maybe you migrate later on. I'm talking about when you're managing a public project. You've put a name and a face to a particular collection of software, you're documenting decisions and tutorials, you're curating a community. Is enabling this sort of flexibility where it is worth focusing the development of your framework? What does the project gain and lose as a result? Now, also, batteries included doesn't mean can't use other batteries, or rather, it shouldn't. A batteries included framework does actually need to make a conscious decision to support the use of alternate libraries. Ultimately, it's up to the project to decide whether they want to make these things possible. The most obvious example here in the Django space is the templating language. There are people who don't like Django's template language for whatever reason. Fine, whatever. Does that mean that if you don't like the template language, you're stuck? No, you can use other template languages inside Django if you want. There are libraries to assist you in doing this. And there's a history of threads on Django's mailing list that says that whilst we're probably not going to change Django's template language by default, we'll support any patch that's necessary to make it easier to swap in any alternative for those who actually do need it. To an extent, TurboGears 1 actually did this. They did publish their list of these are the bits you should use. This is what you should start with. The catch is they also made a very big noise about how everything was a choice, and they put a lot of weight into you can pick something else argument. Replacing core components like this isn't a major focus of the Django community. Sometimes these decisions, the value you place on stability versus flexibility and the importance of having the flexibility to change core components of your system will hinge upon how mature the ideas around your framework actually are. Django emerged publicly in 2005. It's roughly contemporaneous with Rails in that respect. In 2005, the idea of rapid web development frameworks based on scripting languages was pretty revolutionary. There was an explosion of new options and a whole bunch of people exploring new ideas. Django just happened to be one of those candidates. And if you go back through history, the first 18 months of Django as a public project saw a lot more backwards incompatible changes than you see today. The formal backwards compatibility guarantee didn't kick in until version 1 in 2008. Prior to that, backwards compatibility was broadly considered to be a virtue, but it wasn't an absolute. We are now thoroughly into the boring period for rapid web application development frameworks. There are definitely problems that need to be solved, but I'd be very surprised if they require a fundamental change to the way we handle, for example, templates or forms. Based upon sort of current environment and me reading tea leaves, I think it's much more likely to be changes at a language level and a hosting level. Again, it's also very, very important to know your audience. It's a common refrain to the Django mailing list that it aspires to be a 90% framework. It doesn't expect that we're going to be able to solve every problem on the web. What we're aiming for is to make 90% of websites basically easy enough to build. Now that does mean, it's an open acknowledgement, that there are 10% of problems that we know ahead of time you're not going to be able to solve with Django. And that's fine. There are 10% of sites that have unusual requirements, genuinely unusual requirements, exceedingly high traffic, unusual traffic patterns. Cal Henderson is one of the founders of Flickr. He gave the very first keynote at the very first DjangoCon US back in 2008. He made the very astute observation at the time that 99% of websites are not in the top 1% of websites. And for the vast majority of projects, engineering time is much more costly than server time. So setting up your projects for flexibility when frankly being opinionated, picking one and moving on would end up being a much better option. If you're genuinely in that 10%, then the best of breed approach may well be good for you personally, may well be beneficial for you personally, or for the project you're trying to use it for. But again, if you're talking about maintaining a public-facing project, actually putting a name and a face and trying to build a community, there are some very good reasons why you may not want to take the best-of-breed approach, at least to the extent that if you do use existing tools, you consider them as sort of a first-class parts of the whole rather than as a completely commodified component of the whole system. One of the reasons this matters is that depending upon how it's framed, the way you talk about best of breed can compromise your out-of-box experience for new users, the experience that a new user has when they discover your project for the first time. If you visit Django's website, you're invited to do a tutorial. You work through the steps, but the only decision you really need to make is what database do you want to use. And even then, the tutorial strongly recommends that you use SQLite if this is your first time out. You now, again, go back to pyramids tutorials. There is a simple tutorial which really does not much more than put hello world on a web page. There's a single page tutorial which suggests you use raw SQLite and Mako. There's a wiki tutorial that suggests you use SQL Alchemy and Chameleon. And then there's 4 other example projects which suggest other combinations up to and including using ZODB. So I want to build a website. What should I be using? Kathy Sierra wrote a blog post a couple of years back called Attenuation and the Suck Threshold, in which she talks about user engagement on new projects. This isn't just talking about web frameworks or software projects. This is about projects in general. What she sort of says in this blog post is if you're introducing someone to a new project, you need to make their zero to kick-ass time as low as humanly possible. A new user has to go from, I know nothing about this project but its name and possible applicability, to kicking a real-world, practical, personally applicable goal as quickly as possible. If that time is low, they get over that suck threshold where they think this project sucks, I suck, the world sucks, I'm just going to go home and eat muffins. They feel like they can do anything. They feel like they can achieve things. Hey, look at this, I can actually do stuff. I can put stuff on the internet. And they're more likely to take the next step and the next step and the next step until eventually they actually get up the ability curve and they're genuinely experts in your framework. The catch is that the lower the suck threshold is, the more likely they are to take the next step. If they get that first goal really, really quickly, they're more likely to go on and go on and go on and tackle harder and harder problems, even if those next problems and the next problems after that are harder and harder. On the other hand, if it takes a long time to get that kick-ass moment, the more likely they are to give up or develop a negative reputation or negative impression of your tool, your product, whatever. Every decision that a new user has to make is one more thing that could make it harder for them to get over the suck threshold. And that's not just about new users either. Marketing people talk about something called conversion funnels when they're looking at sort of sales processes for products and websites. And it can be very helpful to think about your project in similar sort of light, in a similar sort of light. The process of engaging with a project doesn't end with starting to use it. It's a long-term thing. If you're thinking about your project as having a long lifespan, which is going to get better and better over time, which is ultimately what open source is all about, you need to think about the long-term angle, the long-term conversion funnel. There are people out there who are potential users for your software. You know, they are alive and have a pulse. They could be using your software. Some of those people will actually do a trial and become new users. Some of those new users will become actual users. Some of those users will continue to use the product and start to answer questions on mailing lists and help and contribute and become community members. Some of those people will start contributing patches and starting to genuinely contribute to the framework and the general environment around the framework. Some of those people will hang around long enough to develop a reputation and become contributors to the members of the core team. And some of those core team people will eventually step up and become genuine community leaders. This conversion funnel is something you need to think about your project, and the kick-ass curve is not just something that happens on that first level moving from potential user to new user. It happens at every step along the way. And again, it's not just about first user experience. Whilst the first kick-ass matters, it won't survive. You as a project won't survive if your users don't keep getting those kick-ass moments. One way to do this is through consistency, progressing from I've just found this project, I can do something with this project, I'm becoming an expert in this project. The more consistent your project is, the easier that's going to be. If you can make APIs internally consistent in your project, that in itself is a form of implicit documentation. Take as an example here, Django's model API is what you use to describe the data you want to store on the database. In this case, we've got a user. We're going to store information about a particular user. User has a name, an age, and date of birth. The name is constrained to 100 characters. Okay, that's all fairly vanilla. We then, obviously, because we've got a user in our database, we're probably at some point going to want to put up a form on the page and ask for that information from a user. And so you've got my form, which has got a name, an age, and a date of birth, with the length of the name being constrained to 100 characters. Not surprisingly, there's a lot of similarity between the two because you're kind of trying to reflect similar sort of ideas in slightly different domains. Now, and as a result, the APIs look very much the same. Essentially, you've got a module and a base class, and that's all the real difference there is. One of the reasons that the similarity is possible in a framework like Django is that the same design process has shaped both APIs. It's certainly possible for independently developed APIs to develop consistency, but it's not an absolute given. It happens by chance, maybe by provenance. One framework gets built before the other, one tool gets built before the other. But internally, at one point in Django's history, someone reported a bug that said that char field in the forms API used max underscore length, but the models API used max length with no underscore. So what? Well, in a batteries included framework, that sort of inconsistency is a bug. You can strive for internal consistency. You can say we want these APIs to be consistent because it is implicit documentation, and you can fix it. If you've got a best-of-breed framework composed of independent parts, is that a bug? If one tool has decided to use camel case and one's using underscores, who's right? Is it pistols at dawn to decide who changes their API? If you're the best-of-breed framework wrapped around the outside of it, what control do you have over either of those projects to make them change? And what happens if one project changes to adhere to the other, and then a second best-of-breed framework comes up that's used the other choice? You've got this tool in the middle that wants to straddle two different camps. Consistency is a form of implicit documentation. Once you've learned Django's model API, you've also learned a whole bunch of things about how the Forms API works, which makes using the Forms API that much more intuitive, that much more consistent. And that in itself is something that makes long-term use just a little bit easier. Why am I making such a big deal about conversion funnels and implicit documentation and moving people through your project? Well, because one of the things that distinguishes between being a framework and just being a long blog post that describes how to tie a bunch of pieces together is the difference, is sort of the end goal. If you're actually trying to develop a framework, it's because you're looking really to develop an ecosystem. You're not just looking to document a whole bunch of independent standalone tools. To explain this a bit better, I'd like to take a quick tangent here and talk about tractors. One of the project founders of Django is a man named Jacob Kaplan-Moss. He's a man of many talents, but his real passion is his farm and his tractor called Tinkerbell. But as well as being great for a great source of farming stories, it's also an interesting source for analogies in software engineering. One of the interesting features of farm tractors that many people aren't aware of is something called the three-point linkage. The three-point linkage has been used on tractors for something close to 90 years. It was originally developed in the 1920s by Ferguson in the UK and has subsequently been adopted by pretty much every farming equipment manufacturer and tractor manufacturer on the planet. It was eventually codified as an ISO standard in the 80s, but that was really just codifying what everyone had already agreed to many, many years before. What the three-point linkage does is provide a very, very simple interface that enables plows, seeders, harvesters, whatever, to all be attached to any tractor. And hitting the backwards compatibility point here, it's been a consistent interface all that time. A farm tool built in the 1930s that adheres to three-point linkage will connect to a tractor that came off the assembly line last week, and vice versa. What the three-point linkage does is change the tractor from being a single-purpose tool to being part of an ecosystem. When you buy a tool, you get a tool. And you can buy a very fine set of tools that will allow you to achieve all sorts of things. The real power comes when the tools are able to work together, which is what an ecosystem is. When you buy into an ecosystem, you're getting infinitely more value because you're not just buying a tool. You're buying into all the possible ways that tool can be combined with every other tool in the ecosystem. This is really just Metcalfe's law writ large. Metcalfe's law tells us the utility of a network increases with the square of its participants. Django by itself is not that exciting. You know, it can do stuff, it can do a lot of stuff, but it is limited. What's exciting is the ecosystem around it. Every time someone writes a plugin or a library that's part of the Django ecosystem, every other package in the ecosystem gains a little bit of value because it's something that's compatible with all the other bits. There's something like 4,000 packages on the Python package index that identify as being Django packages. And even if you consider that Sturgeon's law, 90% of everything is crap, that still means there's 400 useful, high-gain projects that you can use as part of the Django ecosystem. But wait, hang on, a best-of-breed framework can do the same thing, can't it? Pyramid can have an ecosystem. Pyramid does have an ecosystem, doesn't it? Well, yes, that's true, but it's nowhere close as being guaranteed. The n in n squared for Metcalfe's law is smaller. The core of an ecosystem is consistency. The reason that the three-point linkage is a useful ecosystem is because it hasn't changed in 90 years and everyone uses it. Every time you change something in your ecosystem, you change the ground rules in your ecosystem, you leave part of that ecosystem behind. TurboGears here is the extreme point. They essentially started a whole new ecosystem. They changed everything. A whole new ecosystem had to develop around the new tools. Plugins and libraries that worked on TurboGears 1, or at least on the official set of TurboGears 1, won't work with TurboGears 2. Pyramid, by specifying nothing, they've constrained the maximum size of their ecosystem. It's not the Pyramid ecosystem, it's the Pyramid ecosystem for users with this particular subset of components they've decided to use. There is still a point of consistency. You know, the Python programming language is a point of consistency there, and there's, you know, an extent to which you say that, you know, Pyramid is really just part of the Python ecosystem and can only use a certain subset of those packages. Same argument really here is what applies to micro frameworks. Micro can be a virtue. Look at how lightweight my framework is. I've only got the bits I need. Now I add an authentication framework and a data store library and a session store and a forms library. And you've ended up with something that's the same size as Django, but along the way you've had to, one, make a whole bunch of active decisions about which bits you're going to use, and you haven't been able to use every component you want because you chose to use Genshi as your template language, and this thing over here only works with Mako and da-da-da-da-da. Now, again, I'm not saying that micro frameworks are bad. What I would say is that sometimes the hype of micro framework gets ahead of themselves. Everyone gets so cool about how small they are and forgets that the endpoint is the big thing that you're building. If you are generally building small websites that are really, really tight and constrained, micro frameworks can be absolutely exactly what you need. But if you are genuinely in that 90% case and you're building large websites, consider the size of the larger ecosystem. Now, to be fair here, the Django community does leave itself open to some very legitimate criticism. Django is part of the Python language ecosystem. It is a Python web framework. But there are occasions where people in the Django community have libraries that have been built and packaged as Django plugins or as a Django library. But if the author had taken a little bit of effort, they might have been able to build a generic library that everyone in Python could use and then wrap it in something that made it Django specific. After all, Django and Pyramid are part of the same language ecosystem. We should be able to share tools, at least at some level. Unless you're talking about something that actively needs to be part of Django, there's no reason for it to be a Django app. Django as a project has actually also contributed to this as a bit of to this problem a little bit for reasons. As I've indicated, out-of-box experience is important. To that end, Django tried to make the out-of-box experience as simple as possible. One of the things we did early on was vendor a whole bunch of libraries. We basically copied entire other projects into our project tree just to make the out-of-box experience a whole lot easier. We also ship with something called the contrib apps, which are essentially a whole other bunch of optional components that ship with Django itself. This made for an awesome user experience, initial user experience, because they just need to get the tarball and then they use it. We didn't do a good job at encouraging people to look elsewhere. We then contributed to this a little bit further by not making Django's internal pieces available, as independent parts. With a little bit of effort, it might have been possible to make Django's template language and ORM available as standalone packages. And this would have been a really great signal to the community that, yeah, Django isn't just one big ball. The catch is that in order to do this, there would have been some architectural issues we need to address, which means we would have needed to spend time and resources, which we already don't have enough of, which ultimately achieves an architectural goal that is really to a secondary goal of Django as a project. So there wasn't a whole lot of internal motivation. Point being, we've kind of led the community astray here. Django did this for a reason. One of the reasons we did this was because Python packaging was a bit of a mess in 2005. It's improved a lot over the last couple of years, and now Django's doing a much better job at telling people to use these various packaging tools and what have you. So, lessons learned. Make sure your language community has good packaging tools. If they don't, fix that as a priority. It also points out it's important to pay attention to the social aspects of your projects and the social cues that you're sending to that community, particularly if you're in a space where you are trying to claim this 90% space, because that means a lot of newcomers are coming to you for their first experience at that language, that community, so on. Community matters. The messages you send to a community affect how your ecosystem is viewed, both with those within and without. A lot of the problems Django has faced is from other members of the Python community are because we haven't communicated effectively what it is we're trying to do as a community. Even more importantly, none of the ecosystem stuff is possible at all if you don't have vibrant, healthy communities around your project. You can't force an ecosystem into existence. The stronger your community, the stronger the ecosystem will become. Toxic ecosystems will either die off or breed nasty subcultures that no one wants to be a part of, which is especially important in open source because your community has to be somewhere that people want to be if you want to get contributors. And again, this really just comes down to your conversion funnel. You need to make it as easy as possible for people to engage. You need to make them feel welcome to progress down the funnel. You need to empower them to progress down the funnel as autonomously as possible. And of course, the single easiest way to improve your conversion funnel is to put more people in at the top, if at all possible. If you, as a project, as a community, are systematically excluding one group of people based purely upon some completely arbitrary distinction or perception of preconceived notions of their interests, you're losing a lot of opportunity to put people in at the top. Django and Python, as an example, are really big in this space with PyLadies, putting codes of conduct on conferences and so on. Completely aside from treating everyone the same, treating everyone as equals, being straight up just the right thing to do. From a completely mercenary perspective, we're putting twice as many people into the top of our funnel, which means as a project we've got a lot more viability long term. Now, wrapping up, I don't think I've got all the answers or that I've got the only answer. Like I said earlier, Django's success was accidental, not intentional. We did things that we thought were good at the time, and post facto, it turns out that many of them were good ideas. I like Django. I like the decisions that Django has made, and that style has worked well for me. It doesn't work for everyone. I've talked about some of the decisions Django has made as a project. The answers that I have given about what's good and what's bad are somewhat shaped by my perspectives. If you value agility over stability, Django's choices probably won't work for you. If you are genuinely in that 10% of edge cases of framework needs, Django's not going to work for you. What's important to remember, and this doesn't mean that the tool is wrong. It means that it is wrong for you. And whilst the answers will be different between different projects, the questions are likely to be very much the same. Whatever the answer, you need to think about backwards compatibility. You need to think about your user experience. You need to think about your conversion funnel. You need to think about the community you want to try and build, the community you're trying to develop. And so with that, finish up. I'll take some questions. Hey.
Just thinking about, what was it, Gears something?
Turbo Gears, yep.
Gears, that when they went from 1 to 2, their users had to kind of change everything because of that. I'm wondering if what might have helped is to have an abstraction layer there so that they could have changed all the plugins on behind the scenes and
yeah, there's no. Yeah, so the question here is, could have Turbo Gears have improved the situation by putting an abstraction layer in place? Yeah, absolutely. There's no problem in computer science that can't be solved with another layer of abstraction. There's also no problem in computer science that can't be made worse with another layer of abstraction. You know. Yeah, I'm not sure, but I'm willing to aim it if there's not. I'll own it if there isn't one. So yeah, an abstraction layer may have helped there, but then essentially what you're doing is building, you know, the abstract API of what a template language can achieve, which then means you're at the lowest common subset of what all programming languages can achieve. You know, taking a subset of that problem. Django has that thing with has that exact same issue with databases. We have an abstraction layer called the ORM, which lets you use Postgres and MySQL and Oracle and SQLite, you know, arbitrarily as a database behind the scenes. We present that as an API called the ORM. The catch is, it makes it, or sorry, the benefit is, it makes it very, very easy for you to swap your backends. The downside is you get none of the benefits of the individual databases at the end of the day. You know, Postgres has really, really good indexing. It has really, really good columns for things like HStore and whatnot, which, because of the way Django's built its ORM, you can get at, but you can't get at in a way that will migrate seamlessly to MySQL, because MySQL doesn't provide those feature sets, and vice versa for that matter. So abstraction layers, yeah, abstract, but you lose things along the way. And you know, people say, you know, you get into situations where people are saying, you know, I don't want to use that abstraction layer, because that abstraction layer hides the feature that is actually beneficial of the template language that I actually wanted to pick in the first place. Hey.
You talked a lot about Django and the correct decisions it made. Were there any decisions where it chose incorrectly?
Okay, so the question is, are there any areas where Django chose incorrectly? The one that I would point out, probably comes immediately to mind, is that we didn't recognise how smart Armin Ronica was until quite late in the piece. Armin Ronica is the gentleman behind Flask, which is one of the most prominent Python web frameworks, micro frameworks, I should say. And interestingly, it's actually started as an April Fool's Day joke and then just got massively out of control. He's also the creator of Jinja, which is a Python-based template language, which he wrote because he thought Django's template language was too slow. So initially, at least, the syntax between Jinja, J-I-N-G-A, it's actually Jinja 2 is the one you want to be using. The syntax of Jinja and the syntax of Jinja is a superset of the syntax that's available in Django. But internally, it's structured very differently. And he was making a whole bunch of stuff about, we should use this, use Jinja, because it's much faster and you get much faster template rendering. And then we probably as a project didn't realise exactly how beneficial the changes he were making were, and then we baked it into a backwards compatibility problem that we now can't adopt it easily as a default because of a whole bunch of other issues about template node structure and whatnot that become a bit of a problem. So yeah, early on in the days, there are some people we probably should have paid a little bit more attention to. There's another example with Python paste that possibly we should have paid attention to. We are now maintaining our own WSGI integration layer where if we'd paid more attention to Ian Bicking early on, we probably would have integrated in. But at that point, we were sort of, no one really knew what the emerging standard was going to be. So it's very easy with post facto to look back and say, yeah, we should have picked that one and that one and that one. At the most recent DjangoCon US sprints, Jacob Kaplan-Moss, again, one of the project founders, in sort of idle conversation just in hallways, said, you know, if, with benefit of hindsight, if we'd known everything we know today, Flask is probably the framework we would have built. Because Flask does a lot of stuff well, with the benefit of, you know, 8 years of past experience. So the difference is that Flask is a micro framework and is missing a lot of the larger community stuff that makes it as valuable. Not to say Flask doesn't have a community, it does, but because it is a sort of a micro framework, it doesn't guarantee that all the parts are going to work with everything, so it's a little bit more complex. So.
Time for one more question, I think.
Hey.
So the things you talk about in this talk, would you apply that to actual user-facing applications, or is it more the fact that
Yeah, okay, so it really is... Yeah, sorry, to repeat the question, sorry. Is this just about frameworks, or is it also applicable to sort of things that are only user-facing, like internal in-house projects type stuff? If you're just using it internally, you're not having to write a 200-page... You print out Django's documentation, it's 1,000 pages of documentation for how you can use Django to build the next thing, or how to build your website and whatnot. That isn't what you're generally going to be doing if you're building an internal project. It's kind of, you've got a bunch of internal tools, you've made a bunch of internal decisions, you've maybe got some engineering documentation about why you did things a particular way, but the end user, you can completely switch this thing out and put another thing in and no one cares because they're not building things that are dependent upon the internals that you're using. So it's not so much applicable to the public-facing project or your internal engineering decisions. This is about, you're going to open source your thing. People are then going to be depending upon the interfaces that are there, either explicit or implicit. You then got to make a decision. Are we going to care that everyone's code breaks if we change this aspect of the system, or if we flush out this part of the system or make it pluggable? So it's less applicable to in-house project type stuff or in-house engineering than it is to public open source project engineering.
Thank you very much, Russell.
Yep.
That was awesome.
Thank you very much. Thank you very much.